This session will discuss about NCERT Class 12, Chapter 2, Inverse Trigonometric Functions, Part 3. Here we will discuss about inverse of sine function. So this is the graph of sine function. In this graph, the x-axis takes the values of real numbers. Okay, the graph of x-axis become the real numbers, and in y-axis it is reaching the region -1 to +1. The graph of sine function is reaching in the y-axis from -1 to +1. In x-axis it is going in all positive, all region of real numbers. So if we take the region from 0 to pi, okay, so the region from 0 to pi if we take, so if we take any point in between from 0 to pi by 2 and from pi by 2 to pi, okay, so at this region, okay, so the midpoint of this one and this one, okay, so 0 to pi by 2, okay, in between this region, if we take the midpoint may be pi by 4, and here from pi by 2 to pi, in between it is 3 pi by 4 we will get, 3 pi by 4, okay. So at the point sine pi by 4 and sine 3 pi by 4, okay. At pi by 4, it may be the mid region in between 0 and 1 in y-axis. So this become 0.5, so 0.5, okay. So sine pi by 4 may be 0.5, and sine 3 by 4 also, 3 pi by 4 also, okay, it is in the same way, getting the same value, okay. So that also become sine 3 pi by 4 become 0.5, okay. So we cannot say the sine functions are 1 to 1, okay. So for this also we are getting 0.5, for this at this point also we are getting same value 0.5. So sine function is not 1 to 1. So if we take the region from pi by 2 to 3 pi by 2, okay, so if we take in this region, okay, so from pi by 2 to 3 pi by 2, okay, from here to here if we take, so the middle point of this one, okay, it will become 3 pi by 4, and in between pi and 3 pi by 2, so pi plus 3 pi by 2 by 2, it will become 5 pi by 4, okay. So the region in between pi and 3 pi by 2 become 5 pi by 4. So 5 pi by 4 and 3 pi by 2. Sine 3 pi by 2 is 0.5, and sine 5 pi by 5 pi by 4 also 0.5, but this 0.5 is positive and this 0.5 is coming in between 0 and -1, so it will get minus 0.5. So at each and every point we are getting different value. If we take the region from plus pi by 2 to plus 3 pi by 2, so each and every point the value of the sine function is unique. So the region, if we are taking strictly, we are getting 1 to 1 function. So sine from pi by 2 to 3 pi by 2, okay. So at this region we are getting 1 to 1 function, okay. So sine function is 1 to 1 on to, so sine inverse exists at this region. So like that each and every region from 3 pi by 2 to 5 pi by 2. So like that if it will go on increasing, and in the negative side also plus pi by 2 to minus pi by 2, minus pi by 2 to minus 3 pi by 2, and from minus 3 pi by 2 to minus 5 by 2, and it will go in the negative side of the real numbers. So if we take those ranges, so in those ranges sine inverse function is exist, okay. Sine inverse is exist in the region sine pi by 2 to 3 pi by 2, sine 3 pi by 2 to sine 5 pi by 2, and if we come in the negative side, from pi by 2 to minus pi by 2, pi by 2 to minus pi by 2, minus pi by 2 to minus 3 pi by 2, minus 3 pi by 2 to minus 5 pi by 2. So in all these regions, the inverse is exists. Minus pi by 2 to minus 3 by 2. Also, we are getting unique value for each and every point. At this point, different value. At this point, different value. At this point it is 0. So then from here onwards, it is getting positive value. So at each and every point, we are getting unique different values. If we are taking the range, branch become a strict range from one higher peak to the lower peak. So the inverse is exist. So in all these branches, this among this, only this branch, okay, this branch from minus pi by 2 to plus pi by 2 is called principal value branch. From minus pi by 2 to plus pi by 2. So this region is called principal value branch. So sine function is 1 to 1 and on to, so that sine inverse exists. So if we take the sine function, sine from the x-axis value become the domain and y-axis values become the range, so that sine from any real number to minus 1 comma plus 1. This is the graph of sine function. So any real number in the x-axis it is going. This graph of sine function is reaching any real number, but in y-axis it is reaching from minus 1 to plus 1. The inverse of sine function, if we want to write, the range become the domain and domain become the range. And the domain also, here the whole set of real numbers, it is possible for sine function. If we want to get the inverse function, we have to take the strict range branch. Okay, we have to split into branches. So sine inverse from, okay, so while we are writing sine inverse, the range become the domain. So minus 1 comma plus 1 become our domain, and the range will be minus pi by 2 to plus pi by 2. So instead of the whole set of real numbers, we have to take the branches. Okay, so sine inverse from minus 1 comma plus 1 to, we can take other branches also, pi by 2 to 3 pi by 2. Sine inverse from minus 1 comma plus 1 to 3 pi by 2 to 5 pi by 2. It will go on increasing in the positive sign, and in the negative side also, we have taken from minus pi by 2 to plus pi by 2. So from minus pi by 2, if we take, this is minus 3 pi by 2. Okay, so this region we have taken already. Now minus pi by 2 to minus 3 pi by 2. So sine inverse from minus 1 comma plus 1 to minus pi by 2 to minus 3 pi by 2. And sine inverse from minus 1 comma plus 1 to minus 3 pi by 2 to minus 5 pi by 2. And in negative side also it will go like this. Okay, we will get infinite set of inverse function from one single sine function. Okay, these are all sine inverse function from one single sine function. And so that here the sine inverse function, in the sine inverse function, the domain become minus 1 to plus 1, and the range is from the region minus pi by 2 to plus pi by 2. So these real numbers we have to take in x-axis, in y-axis. This pi by 2 we have to mark in y-axis, and it is reaching the region minus 1 to plus 1 in the x-axis. This is x-axis and this become the y-axis. So if we plot the graph of sine inverse function, it will come like this. So in the x-axis, it is reaching from minus 1 to plus 1 only. But this y-axis, the graph of y-axis, it is going on in the real numbers on the positive as well as the negative side. So that if we plot this both of the graph in one single graph, so that this is the sine function, this is the sine graph of sine inverse function. If we plot both of the graph in one single graph, and if we draw a line of y is equal to x, okay, so this line is splitting a midway at the origin. So if we take one side of this line, so that the sine inverse, the graph of sine inverse function is exactly placed on the graph of sine function on this same side of this straight line. Okay, so this become the graph of sine function become the image of sine inverse function. And if we see the other side of the straight line also, the graph of sine function become the image of the sine inverse function. Okay, so sine function, sine inverse is the image of sine function. Now on the whole, we can write this sine function, sine inverse function from minus 1 comma plus 1 to the principal value branch minus pi by 2 to plus pi by 2. So this is the basic domain and range of sine inverse function. So sine inverse from minus 1 comma plus 1 to minus pi by 2 comma plus pi by 2. This is the domain and the range of sine inverse function.